Okay, going to continue to let our attendees start filing in. But good evening, everybody. And on behalf of the NF Network and NF California, we'd like to thank you for joining us for tonight's webinar, ADHD, Learning Differences in Autism and NF1. As a reminder, tonight's webinar is being recorded. Dr. Tamar Green will present on neurodevelopmental conditions and how they present in NF1, as well as treatment options and study results and opportunities. We hope to leave time at the end to answer some questions, so please feel free to utilize the Q&A box or the chat box to submit your questions. Our speaker tonight, Dr. Green, gained her training as a child psychiatrist at Tel Aviv University in Israel. She has completed a postdoctoral research fellow in neuroscience at the Center for Interdisciplinary Brain Sciences Research at the Department of Psychiatry and Behavioral Sciences at Stanford University. Currently, she is an assistant professor at the department. Dr. Green, we'd like to thank you for joining us tonight and for presenting on such an important topic in the NF community.
Hi, everyone. Let me just share the screen and start. So, you know, it's weird to talk to a computer, but we're going to try our best. At the end, we're going to have a Q&A session. So you're more than welcome throughout the session to type your questions in. It's going to help us answer more specific question. It's very, very, thank you so much for the invitation tonight. And I'm very excited to present. I have a lot of experience in neurogenetic syndromes and in the study of children with genetic disorders, but NF1 is a new field for our lab. So very interested also to hear from you and see that what we think is what you think and learn from you, because that's the best way for us to do science. I'm going to talk today about neurodevelopmental disorders in NF1. The agenda for today is going to be, I'm hoping to speak for 40 minutes and then have time for questions. And the agenda for today is to do an introduction to ADHD in general and executive functions. This is one of the neurodevelopmental conditions that we're going to talk about, but this is the one that I'm most focused as a clinician and a scientist. And also we can, by learning about that, we can also infer about other developmental conditions because they tend to follow the same path along development. After that, I'm going to provide an introduction to behavioral genetics, and this is the research approach to children with genetic conditions, including NF1. Then we're going to dive into neurodevelopmental issues in NF1. And after that, I'm very interested to tell you a little bit about our lab and our research, so you can have a better understanding into what we do and what we're hoping to achieve. And at the end, I'm going to kind of wrap it up with the clinical aspects that I think that many times are very helpful for parents, and questions and answers. So what is ADHD? ADHD stands for Attention Deficit Hyperactive Disorder. I want to emphasize that this disorder is defined by behavior and not by disease mechanism. What does it mean? All of us know about COVID today, and COVID is caused by a virus, and we know a lot about, we don't know enough about COVID, but within 9 months, we were able to develop a vaccine to COVID virus, to COVID disease, because we know the disease mechanism, we know what caused it, and we can follow and find solutions. In psychiatry and in neurodevelopmental disorders specifically, we are not able to do that because we don't really know the disease mechanism. So it's important to understand that in the disorders I'm going to talk about today, we do not know the disease mechanism, and this is one of the goals of why we want to do research about it. The prevalence of ADHD in general, in the general population, is boys around 13%, and and they're more likely to be diagnosed than females that diagnosed in 5.6%. So what are the core clinical symptoms of ADHD? So the disease, as I said, is defined by behaviors, and the behaviors are inattention, hyperactivity, and impulsivity. Inattention is a tendency of the child to have difficulties in sustaining his attention for some period of time. How do I know how long a child should sustain attention? So many times we go by school. A child who enters school, kindergarten, or first grade, supposed to sustain his attention for 30, 45 minutes. It is dictated by the school system, but also it connects to development. If you think about a young child who's like 2, his attention span is shorter. A child who is at school age, his attention span increases, and for adolescents, now I have adolescent kids at home, and they are supposed to be focused for an hour and a half. So it's something that increases as kids grow. So the difficulties are with sustaining this attention, listening to in class or to requests. On top of that, many kids develop a tendency to avoid or dislike mental effort because mental effort is difficult. So it's a tendency not to like it. Instructions are difficult to follow, and many of the things that I will ask parents when I see the child clinically is how many instructions they can follow in one batch, meaning like if it's one instruction or 2 or 3, like I can ask a child in the morning to put his clothes, to brush his teeth and comb his hair. So how many of those a child can remember to follow? And other things might be organizing his desk, tendency to lose things, and other things that might be affected are the distractibility. So it's not only sustaining the attention, it's also if something interrupts in the middle, how the child reacts to that and how much he can come back to what he was doing, or he's completely kind of like lost. The impulsivity, hyperactivity are easier to, I think, understand because they're more observed. So in class, it's a child that leaves seats and fidget a lot, unable to play or engage in activities quietly, cannot wait in turn, or tends to interrupt parents while they speak on other things, sometimes speaking without even noticing that someone else is not listening. And while that is, those are behaviors that presented while the child is young. Where in adolescence, there's a tendency for these activities to reduce, but there is a feeling of internal restlessness. So many of the adolescents will not be hyperactive and observed like running around, but this restlessness stays and it's more internal feeling. So we talked about the core symptoms. We're gonna chat tiny bit about how things look across development and the effects of having these core symptoms on in childhood, adolescence, and adulthood. So in childhood, we'll see effect on academic problems, tendency for injuries. So kids with attention problems, ADHD, have higher tendency to get injured, and they have more visits to the ER departments. Healthcare costs are increased. And in this study, they called it replacement costs. And what they mean is that parents need to buy a lot of things twice, like buying twice the iPad, buying twice a notebook, because the child tends to lose them. In adolescence, academic problems will continue, tendency to injury will continue. There are more sexual problems because of the tendency to be more impulsive. So that might increase. And again, healthcare costs and replacement costs are increased. In adulthood, because adults don't visit school, the difficulties will be in employment, and people with ADHD tends to be less employed or employed in positions that are lower compared to their abilities, and all the other issues that I described in adolescence continue. A little bit more about development. So in the very young age, the temperament is, the activity levels are increased. There's emotional intensity in the sense that every emotion is very big. Happy is very happy, sad is very sad. There's decreased ability to be soothed, and the child can appear alert and more alert and less rested. The predictors for how severe the ADHD gonna develop is the severity of the early behavior pattern. So if a child patterns only start to appear when he's third grade, he's gonna be less severe than kids that these patterns were observed at the age of 3 or 4, and it makes a lot of sense. But also the negativity of the parent-child interchange during preschool years. Why is that happening? So one of the thoughts is that the child is it's harder to handle him. So there's a tendency to engage in a negative way with the child. It's no one's fault, right? It's not the fault of the child and not the fault of the parents, but the challenges are much higher. So many times we see difficulties in the parent-child connections. There's, as I mentioned, in adolescence years, there's mental restlessness, there's issues with impulse control and self-regulation, hence more issues with sexual issues, more tendency to use substances because of those tendencies. And in the adult life, one thing I want to kind of focus on is that only half of the people with ADHD will still meet the criteria for ADHD, but only 5% will do it if you ask them. So it's a disorder that the insight to having it is not very high. So it's a bit tricky to diagnose it, and many people who have ADHD as adults tend to blame themselves for what's happening to them, like tend to blame themselves for being impulsive, tend to blame themselves for losing jobs. And that, of course, have a cycle on affecting the self-esteem. And finally, I want to focus on comorbidity, and we'll talk about it a lot in the context of NF1. Is ADHD is comorbid with other disorder. Comorbid, it means that when we see ADHD, we always look for other things because they tend to come together. So in the younger ages, it's comorbid with intellectual disabilities, with anxiety, with tendency for tics. Tics are movements that are involuntary, like, or motor tics will be something that looks like that or like that. And other psychiatric conditions. In adolescence, what will add to that is mood disorders like bipolar and depression and behavioral issues. And in the adult age, it's as I mentioned, we can see already substance use or personality issues, meaning that the personality is very rigid and cannot adjust. And the last axis I'm going to talk about is the family burden that increase because of the comorbidity and because of the longitudinal nature of the condition. So this is kind of like to summarize this section and to hopefully I can convey the complexity of having ADHD. For many times people think about ADHD as attention and that you need to correct it with medications and that's it. And the goal here is to show how complex is that, how it changes through development and how it puts an individual at risk to having other conditions that also need to be looked at and addressed. So what are the risk factors to develop ADHD? So first of all, it's very, very heritable, 75%. Higher than depression and higher than schizophrenia. So it's very heritable. There's other biological reasons that are not genetic, like low birth weight, maternal alcohol use, maternal smoking, iron deficiency, lead, and many other biological conditions that could contribute to ADHD. Also, if we have another mental issues or even physical issues like heart disease or diabetes, it exposes to ADHD. Environment, as I mentioned, there's the parent-child relationship, but also achievement pressure, ever-present media or ever-present electronics are very, very distracting. So that can also affect our level of attention and parenting. So when the attachment is the ability to connect with a caregiver. So if it's interrupted, we'll see more ADHD and in extreme deprivation. But those reasons needs to be very extreme. It's not having an argument with your child. It's most of these studies were done on children who were orphans who grew up in facilities without parents. So it needs to be very kind of like just to understand the proportion here. My goal here is to convey that genetic factors are recognized as the critical etiological component of ADHD. As I mentioned, 75% heritability. But the genetics is very multifactorial, meaning there's a lot of genes that contributes to that. And because of that, it's very hard to detect the disease mechanism. I'm bringing you back to the example with the COVID, that we know the disease mechanism, we know what causes the disease. And because we know what causes that, we can learn about the mechanisms in a much higher pace. So now I hope you have some introduction to ADHD and how we think about ADHD. And I want to move to introduction to behavioral genetics. And this is much kind of like I'm taking you now to the NF1 world and to the world of genetic conditions and connecting those two concepts. So why in research are we very interested in learning about genetic conditions and children with genetic conditions is that for higher cognitive functions like ADHD, it's very difficult for us to learn from other models. What do I mean? If we, in many diseases, we study mouse disease models and we can do experiments and do manipulation and learn how to solve problems in medicine. But when we talk about ADHD or talk about neurodevelopmental conditions like autism or learning disabilities, it's very hard to create those models in mice because they're not humans and they don't think like humans. So it's very, very difficult. On the other hand, there's many kids who suffer from ADHD, but as I said, the genetic contributions are so diverse and so many, and each one of them is with such a small effect that there's high heterogeneity, so it's very hard to learn about genes or cellular mechanisms. And this is the reason that our group and other groups are very interested in human disease models. And when we say that, what we mean is that we are very interested in learning from children who have an identified genetic conditions like NF1 and like other conditions, because they present with the complex behaviors and also with relative homogeneity. And just kind of like to show different conditions with different effects. So on the left, you can see chromosome or genes that are being affected in different conditions. So in Williams syndrome, it's going to be chromosome 7. There's a deletion there. In Fragile X, there's effect on the genes. But more to our subject is neurofibromatosis. As many of you know, there's a mutation in the NF1 gene. And children with neurofibromatosis tend to present with 55% of them will have ADHD. Another related condition is Noonan syndrome. Is also a rasopathy, meaning that it affects the RAS-MAPK pathway like Noonan syndrome, and 34% of them will have ADHD. So you can definitely see that compared to the 13% of boys and 5% of girls in the general population, these children tends to have these symptoms in a much, much higher rates. So it gives us a clue that the NF1 gene is affecting brain development and affecting the behavior. And I'm not gonna be very specific here, but I just wanted to show what I mentioned, the Rasopathies and NF1 and Noonan syndrome are genes that encode protein and the same pathway. And this is a great model for us to understand and to investigate, because we do think that this is the way to get to the mechanism and understand what's going on and being able to help better. So now we're going more to the clinical parts of the talk, and I'm going to talk about neurodevelopmental issues in NF1. And oh, sorry, this is okay. So the neurodevelopmental disorders in children with NF1 include effect on cognition, specific learning disorders, attention problems, and overlap with ADHD, as I just mentioned, social deficits and overlap with autism, and mood and anxiety disorders. Effect on cognition, there's several points I want to make. So at the beginning, meaning like, I think 30 years ago, there was a strong belief that NF1 is associated with severe intellectual disabilities. And when I say the intellectual disabilities, I mean that the IQ, the general intellectual performances are below 70, and there's effect on behavior. And so it was estimated around 20 or 30%. But now we know that those were generally overestimations, and only 4 to 8% that are still above the 3% in the general population suffer from what we call intellectual disability. And this is, I think, very encouraging for many families. However, we do know that if you look on this, on the image on the right, you see in blue the average cognitive ability. and I'm talking about A, the top one. So the average cognitive ability goes, and this is in the general population. I'm giving now data from another syndrome, but I do want you to, it's just for to understand, is that another syndrome called 22 deletion syndrome pushes the cognitive abilities downwards, meaning reducing the cognitive abilities compared to the general population, in this case, in 20 points of IQ. In NF1, same process happens, and what we think is that the NF1 gene pushes the expected IQ by 15 points of IQ, 1 standard deviation. So again, we do not think that we know that NF1 is associated with slight increase in the rates of intellectual disabilities, but and this is slight, but we do think that on average, compared to the parents, a child with NF1 will have a reduction in his cognitive abilities that if they're measured in a very, very general way, it reduces 15% of his IQ. There's an exception for that because there's one type of deletion, 17q11.2. It's a 1.4 megabytes deletion of the chromosome. And their kids with this variant will suffer, 50% of them will have intellectual disabilities. What's much more common is for kids with NF1 to have, to meet criteria for specific learning disorders, compared to 20% compared to 10% of the general population. So what are specific learning disorders? And I want to say that criteria has changed. So here it's important for me for parents who have kids in the school system to kind of attend to that, because it's important when you communicate with school. So learning disability is a substantially lower performance in reading, writing, or math. That is not otherwise attributed to lower general cognitive abilities or comorbid medical condition, meaning that if a child is functioning on a lower than average IQ, let's say 70, and it's harder for him to read and write or to do math, we kind of expect, in a way, we expect it to be harder because the general cognitive abilities are lower. But if a child functions in an average IQ, and he do well in math, but does not do well in reading and writing, then we kind of expect specific learning disorder. And what I emphasize here is that this disorder continues despite targeted intervention. So first, we need to try and intervene. We need to try and help the child in a very specific way. And if we're not able to, then we're going to start to talk about specific learning disability. In the past, there was measurements of the discrepancy between performance and IQ. As I said, like if a child had an average IQ, there would need to be a specific gap between that and his abilities, and that's not longer needed. So when you communicate with school, and if you hear that, I would ask you to correct and say, no, it's not needed anymore. What's much more needed is to try to specifically intervene and to show that there's no improvement. But something else is that I'm telling you that 20% of the kids meet criteria for specific learning disorder, but 75% of the kids with NF1 will require some type of school accommodation or a remedial teaching. So what's going on? What I think is going on is that many children, even though that they read and write or do math very well, they do struggle with other cognitive deficits or weaknesses. One of them is in executive function. I'll explain what it is, or with visual or spatial perceptions that are much more basic cognitive abilities. And because they are affected, the child is struggling, but it's much harder to detect that or to put that in a box. So what are these executive function skills that I'm talking about? And I'm sorry for the quality of the image, but just for the explanation, is our ability, let's say I'm a child and I'm 3 and I want to build a castle in the sand. So mentally, what I need to do is I need to think about a castle. I need to represent that in my mind. I need to plan how I'm going to do it. So I need to bring my blocks or to ask for my mom to bring the blocks. And then I need to execute that. And then I need to evaluate if what I did, is it resemble what I had in my mind, or I need to do any changes. And all of these processes requires executive function skills, because I need to plan and execute and evaluate all these actions are high cognitive actions that sometimes affected in NF1. So we talked about intellectual disabilities, we talk about learning disorders, and I now talked with you about executive function, and something that relates very closely with executive functions is attention problems, because they many times go hand in hand, meaning that a child with attention issues will suffer also from weaknesses in executive functions. And children with NF1 have a specific deficits in attention. They tend to be more inattentive than hyperactive. So many times we'll diagnose them with the inattentive type. And this is also make them more prone to be missed in school, because they're not hyperactive. They don't interfere. So sometimes they kind of like go under the radar. 50 to 60%, it really changes by the studies of children with NF1 will meet the criteria for ADHD, but it doesn't mean that other kids don't struggle with attention. They just might not meet the threshold. The etiology of ADHD is much, and this is a hint for our brain imaging studies, they're related to brain system that relates to dopamine and neuroadrenergic systems. And this is what the medications, when you hear about Ritalin, Concerta, Adderall, this is what these medications are targeting. These are the systems that the medication are targeting. And I want to say that there's strong evidence that stimulants medication are beneficial for ADHD symptoms in NF1. So the data shows that we can treat them in an efficient way, and we should not avoid treating. Of course, we need to take other things into considerations like cardiac malformations or issues, but definitely it's something that is recommended if the symptoms are disturbing development, interfering with development. And I just want to come back to tease you and to throw a teaser that the striatum is very much connected to this dopaminergic and noradrenergic systems. And the striatum is a small structure you see here on the right in blue, and so it's a small structure in the brain. It plays a critical role in ADHD and in the NF1 gene, and the NF1 gene, it specifically affects it. So we'll talk a tiny bit more about it when I'll introduce you our brain imaging studies. And lastly, this is a really kind of like growing body of evidence that shows that there are significant social deficits that in NF1 that overlap with autism. So what happened, like the development of this thought scientifically were as follows. So at the beginning, like let's say 30 years ago, the children with NF1 were observed to have significant social deficits interacting with their peers. The the thought was to, back then we were attributing that to physical stigma, like the thought that maybe a child with NF1 look differently, and that's the reason it's much harder for him to socialize. Later, there was a thought that maybe the ADHD symptoms are the ones that affecting that, because we know from the general population of children, the children that suffer from ADHD in the general population, that many of them present with social deficits because they're just not attentive enough to interact and develop those skills. And a large study, and this is where it's a very good example how participating in research helps so much to change what we think about things and what the reason to things, because this study is a multi-center study that included over 500 children. Maybe some of you have participated. And that study really changed the way we think about social functioning or autism in NF1. What this researcher did, they did two simple things, but very important. They gave parents a questionnaire that's called SRS, that measure the level of communications and repetitive behaviors. So how the child is communicating with his environment and how many repetitive behaviors that he has. This is the two core symptoms of autism. And also to fill out questionnaires about attention span. And what they found is that, you can see here from the right, is that the first arrow that says general population SRS is most of the kids in the general population will fall under in scoring 51 to 55. On average, the whole sample of children with NF1 scored 20 points above that, 10 points above that, so 60s and above. And 13% of the children with NF1 scored above the threshold, the most severe range, above the threshold that is 75. And that puts them in a very high risk to actually be diagnosed with ASD. The diagnosis of ASD of autism cannot be done by questionnaires. So I don't want to convey the idea that you just give a questionnaire and you need to do a much more in-depth assessment, but SRS above 75 definitely put a heavy suspicion about having autism. So this study then also showed that these symptoms are not only due to effect on cognitive abilities or ADHD symptoms. So it could really show that deficits, there are core deficits in social functioning. So now we move on to how research work, I call this section, and tell you a little bit about our innovative new study in NF1 that we're really hoping that you will consider participating in. And I want to give like a very, very short and brief introduction to brain imaging, because I think it's important to understand and also might help people to decide. So we have different types of brain imaging. Brain imaging, basically, like in a very simple word, it's our ability to look at the brain and understand how the NF1 gene affects either the structural images, which you see on the left, or, and this is the gray matter of the brain. If you can think about the brain as a lot of cities that are in the nation, a lot of cities that sits, each one of them is special, something special about that city. So you can think about our brain like that. Each region has special abilities or responsible and special things that we do, or specific things that we do. And on your right, you see the diffusion weighted imaging that image the white matter of the brain. And this is, if you think about the cities, so the white matter are going to be the roads that connect these cities. So there's very wide roads or very wide white matter tracks or very narrow roads. And we know that NF1 also affects those regions. Oh, sorry. And another type of imaging that we do is we do structural MRI, as I just explained, looking at the gray matter volume and then white matter, but we also do functional MRI. And in the functional MRI, the goal is to reveal the brain function. So if it's Homer here, and this is his this is the anatomy of his brain, implying that he has a very small brain. But if you look at the function, you see other things. You see what he thinks about. So it's mostly sleep and donuts and sweet and beer and all the things you can see in the cartoon. I'm sorry, but this is a dense one. This is a dense, and this is the most challenging part of the talk, but bear with me. So why do we even need brain imaging studies in NF1? Because, what we care about eventually is how the child behaves, how he's doing at school, how he's doing with friends. So why looking at the brain? So as I hopefully convince you that there's increased susceptibility to the neurodevelopmental disorders like autism and ADHD in NF1. And several intervention studies using statins and other compounds have failed to show an effect on the symptoms of learning and attention. And I'm bringing you back again to the fact that we don't know what causes these behaviors. So if we don't know what causes the cough in COVID, we cannot solve it. So this is our way to understand what's going on. And I think the reason we are still looking is that the brain is such a complicated machine. So when we try new drugs and we try new therapies, we don't see an effect on behavior, but we do see that NF1 affect the brain, has a very big effect on the brain, both on structure and on function. And this suggests that behavior is not that we need to measure behavior when we try new things, but it might be that if we understand more about the brain, when we try new things and try new interventions, we can actually measure them better and decide if they're working or not working much better than only looking on behavior. And now I'm going to tell you about our current research and the reason that our lab is interested in NF1 and starting to study NF1. And this is following a grant we received. This grant, the reason that I have this picture is, oh, I'm sorry, this is a little bit kind of like, the font is overlapping, but this is Dr. Francis Collins. He's the head of NIH. And you probably saw him a lot during the COVID pandemic. But how he connects to NF1, maybe some of you know that he's the researcher that discovered the gene for NF1. And gladly, he's still interested in NF1, in funding research in NF1. So we received a grant to look on the brain function and structure of children with NF1, and trying to really tease out what's specific about the brain of NF1 and what we can measure for future intervention. I'm bringing you now back to our kind of like model of how we model genetic, protein, cellular, brain phenotypes, cognitive phenotypes, and behavioral phenotypes. And the idea behind this study, this is a very complex slide, but the idea here is that there's other syndromes on the Rasopathies, specifically NF1, Noonan syndrome. And those syndromes, Noonan syndrome is very similar in the neurodevelopmental conditions to NF1, but we know that they actually have opposite effects, both on the RAS and APK pathway and on the brain. And we think our idea is, our lab is the first lab that ever scanned and studied kids with Noonan syndrome. And now what we are doing is adding to that children with NF1. And once we contrast them, we will know what's specific about the brain of NF1. And we also can apply new innovative ways to analyze the brain of NF1 and understand much more about it. And just kind of like to show you how things look at the end is that we have different levels, the levels I explained you. So for example, in NF1, we know that there's a reduction of the striatal volumes, these small brain regions that affect ADHD. In NF1, we know that there's increase in the striatum. So we are really interested in contrasting them and understanding what the NF1 gene specifically does compared to kids with Noonan syndrome and compared to typically developing controls, compared to the general population. Same things with white matter. This is a different situation when both in NF1 and in Noonan, we know there's a reduction in how well the white tracts lead information, but that was never tested in NF1 compared to another rasopathy. So we want to do that as well. And the same idea with functional connectivity. So we are going to look how the brain is functionally communicate. So so our goal is, like, you probably understand that my holy grail is understanding pathophysiology, and we think we can understand NF1 better and help kids with this very messy and very, very complicated system that's called our brain, and tease apart what happens in NF1 and how we can target that and intervene. And I'm going to conclude with clinical aspects of ADHD and neurodevelopmental condition. It's much more down to earth section. So I hope it's going to be helpful, and I'm very happy to answer questions about it soon. So just to remind everyone that when I say behavior, it's the way that one acts and conduct oneself, and cognition is the mental action of processes of acquiring knowledge and understanding. So just when we think about school and we think about how a child behaves at home, so kind of like trying to start and separate between how he behaves and how he thinks, because many times if we understand how a child thinks or the difficulties in how he thinks, we can be less upset about the behavior because we understand it better. So that's the reason I'm doing this discrimination. So things to do at home, for example. So one thing is to acknowledge that problems with child attention and executive functions it's disrupting the whole family routine, because it's, as I said, giving instructions, every instruction, you cannot give a bunch of instructions and the child is ready in the morning. So you have to break them apart. There's a lot of fighting and arguing over doing homework or doing mental. So all of those really disrupting. These difficulties can also in the child himself can lead to frustration, anger, and acting out. And parents many times feel helpless and resentful because they cannot help their child, and the child is having a lot of difficulties, but also sometimes there's a lot of behavioral issues that amplify amplify the issues at home. And the way to kind of navigate out of that is to identify patterns of strengths and weaknesses, which basically mean like to map it out, to map like what my child is doing well and what is more of a struggle for him, because that will impact what we do later on. So the meeting, so what do we do at school? So we do need at school to assess academic and cognitive functioning when we think the child is struggling. So when we meet at school, what should we expect? So we should expect the teacher reports, we should expect a classroom observation, and we should expect, you the parents should expect that the school will give you some self-report, some questionnaires about your child. And the main question is, does your child appears to be on track developmentally? So in preschool or early school, can he do simple chores? Inhibiting behaviors that are not appropriate, like urinating in the middle of the classroom or in the playground, can manage small allowances, and in late school and adolescence, it's can he carry daily responsibilities for chores and tasks, caring for younger siblings, organizing schoolwork and assignments, carry out long-term assignments. So just kind of like to orient. And diagnoses that commonly are associated with NF1. So kind of like remembering those things that we talked about are attention, hyperactivity, oppositional defined disorder that I didn't specifically talk about, but this is all the behavioral issues that a child can be defiant and argumentative and not do what he told, and fight a lot with siblings and other not accepting authority from adults. Other issues might be autism spectrum disorder and learning disorder. So all of these neurodevelopmental issues are very much connected to school, because this is where this is the work for kids, right? So it's a major aspect of their lives. So when we interact with school, we need to be aware of them. And it's very useful to think about less in diagnoses and more like in symptoms and how we can help the child. What we can do at home is always think what's appropriate for his development or her developmental level. So not expecting too much and too low. It's a moving target. So it's not easy, but think about it as a moving target and not something like constant. Every time a child, once he achieves one milestone, he needs to move to the other one, but he cannot achieve like the 5th milestone before he achieved the first 4. So remember that. Use a frequent situation as teaching moment throughout the day. Utilize, so this is a very important point. So many kids, it's very difficult for them to only utilize like hearing you asking something. So utilize other things like making eye contact. If the child is not making eye contact, you can grab his head and make the eye contact and help him visually to see that you speak to him and asking him for some or her for something. Gestural prompts and cues will help that repeat themselves and prepare the child for things, also very helpful. Asking your child to lead, make her a partner in the learning process, and try to assist and not to replace, not do the homework, but assist with the homework. And persevere. With many kids with developmental difficulties or weaknesses, perseverance is what's like doing it again and again and again until the child can master that. That's the key for many of the developmental difficulties. And with mastery, start to introduce more complex tasks. And once a child masters something, also remember to fade away, because many times when we have a child with condition, we got so used to do things for them that we forget that they master that, and you can fade away now. That this is also sometimes a challenge for parents. So frequently use opportunity to praise your child for things that sometimes even seems trivial to you, but they're very important in order to implement the behavior and reinforce skills that are already been used well. So don't forget to say good job on things that the child mastered, because we many times forget it. We only focused on the things that the child doesn't do yet. I'm kind of like looking at the clock. I'm now talking more in general terms, not in diagnosis specific, but in all the neurodevelopmental conditions that I mentioned, early identification makes a big difference. Intervening early, understanding what's the area of weaknesses and where we should put more effort makes a difference. Don't be shy from family counseling and guidance. Behavioral problems should be addressed early and intensely, because they can be addressed through parent-child behavioral training, or if it's more on the social aspects with peers in social skill groups. And now when schools are reopening, we can introduce that again, and sometimes with medications, but we tend to very rarely use medications for behavioral issues. Placement in an optimal educational environment is critical and not very easy, and supportive home approaches that I mentioned before. I'm going to go quickly on school accommodations. Sorry. So these are, again, general, because we were talking with, like, a very diverse audience. So the recommendation are general, but seating arrangements sometimes make a difference. Also, if there's any visual issues that are common in NF1, so seating is very critical, and making sure that the recommendation actually being implemented. Extended time for homework and tasks. Reduced workload, sometimes very helpful. Curriculum that I would say many times we know how to deal with the weaknesses, but sometimes it's very smart to push on the strengths, because then the child can build on them. And again, the same way as at home, information should be presented verbally and visually, like in multiple channels. And assisting in organization can make a lot of difference. At school, many times there's a possibility to ask for functional behavioral analysis if it's someone that understands reinforcements and behavior and can observe the child in the class and kind of come up with a program of how to help him to do better by shaping some of the behaviors and rewarding the adaptive behaviors. This is a very concrete example of a behavioral chart that there's task and the child gets stars for achieving goals, but I really recommend, it's really hard to implement it yourself. So either read about it or there's a short intervention that's called parent management training, and they're very helpful in teaching. It's kind of, you do need to understand how it's being done and be supported through the process, because it's sometimes difficult to do it yourself. And now I want to switch to Tammy, who is our research assistant at the lab, who will join me and present our current study that we're hoping you guys will consider to participate in.
Hi, everyone. Very good to be here. I'm Tammy. As Tamar said, I'm a research assistant in the Bridge Lab, working with Tamar and all the rest of the team. I want to tell you a little bit about the study that we're doing right now. It's a beautiful study. We already started seeing kids about a month ago, maybe a month and a half even. Kids are coming. It's actually 2 days of 2 days for each kid. The first day is in Stanford. It's in the lab, and it's actually it has two parts. The first part is the MRI scan of the brain, and the second part is the tests and games for the kid, which usually is done by our psychologist, the child psychologist in our lab. We're looking for kids ages 5 to 13. So for today, I'm going to say that we're looking for kids who have NF1, but we also look for kids with Noonan and typically developed kids as our control group. So we also do a physical test for height, weight, and the kids are asked to give a saliva test. It's just a small sample. It's not very hard for them to give. And kids sorry, I forgot to say the second part is the second day. It's a remote day. It's also being done by our child psychologist, and it's actually more tests and games for the kid. Kids usually have fun when they come. It's games and it's like IQ tests, but for kids, it's basically games. And most of them say that they had a good time. Some of them come because of the money, and we have an honorarium when you finish everything of $100. Some kids come because they're interested. We actually, it's very important to us to explain everything to the child, to show them a picture of their brain, to tell them what they're doing, why is it important. We show them stuff at the lab. So some kids come because it's just really interesting for them. And some kids are like, they just come because they want to help research, and they understand how important it is to us and to the rest of the kids we're trying to help. So that's basically it. That's about the study. We're recruiting, so if any of you are interested, you can contact us by sending an email. It's right here, or calling. This is my phone number. I'm always happy to answer questions about the study and tell you more. And I'm available with calls and texts. And here we have the Facebook page, which we have now. It's quite new. We're working on it. It's for the study, and it has some info about the study. So you're very welcome to go and see. So as I said, the study visit, this is just a few pictures of, we have the MRI scan, the assessments, the saliva sample, and the iPad games in which we do the IQ tests.
Great, thank you. And we're just going to show you our research assistant that does the psychological evaluations. She wanted to greet the kids and introduce herself. Her name is Sarah. So we're just going to play a short movie.
Hi, my name is Sarah. I work in the Bridge Lab with Dr. Tamar. I'm a research assistant and also a fourth-year doctoral student in clinical psychology. I'll be doing a lot of the assessments with our kids and families who join our study. I'm really, really looking forward to meeting all of you and getting to work with you all. So hopefully I'll see you soon.
So thank you, Tammy. And I just want to emphasize that we also, for our families that come from far away, because there is an issue of traveling to Stanford. So we do cover travel, even if you need to come from a different state. So this is something that our funding allows us, and we're happy to do. I'm just going to wrap up with why do I think that it's very important to participate and come. It's always kind of like, I think there's a tension between overburden your child and dragging them to more tests. But we do think that for many, it's better to know than not to know your own profile of strengths and weaknesses. And this is something you can get out of participating, because we do give, indeed, research report, not a clinical report, but we do give you some map into, and many families then can follow up with school and ask for more formal testing. This knowledge is not deterministic in any way. The way I think about neurodevelopmental condition, that even there's a weaknesses, now you know what to target, and now you know what you can change. So in my opinion, it's a really something that places you in a state of that you have the power to change. And knowledge potentially gives you a greater capacity to voluntarily work at change, as I said, utilizing strengths and in a more general way, it's a good opportunity to help the NF1 community and kids with NF1 to kind of like pave the way to more specific treatment. And in our case, we care, as you probably understand, care very much about child development and helping with cognitive and psychiatric challenges. So that's about it. I want to say thank you for everyone, especially for Tammy, who joined today. And also to thank the NF1, the NF network and California network and NF California for inviting us. And this is kind of like the people in green are the people that currently participate in the study and the data that you saw today. So, and to thank our funding mechanisms through the Francis Collins Scholar and NTAP. That's it.
Wonderful. Thank you so much, Dr. Green and Tammy, for presenting on this very important topic. We do have just a couple of questions. I know we're a little bit over time here, but we do have a couple of questions in relation to this study that I thought we would start out with here. Let me pull open. So we have a question. My daughter already sees a neuropsychologist. Could this be done here in Canada with her current BrainWorks team?
So unfortunately, it's very hard to, actually most of the testing we can do online, but the scans are very specific, and we have very specific sequences, and it's not a multi-center study yet. So we do want you to visit Canada, but visit Stanford, sorry. But I suggest to anyone who's interested but not sure, you can contact us. We document like your situation and what you're interested in, and maybe when travel from Canada, I know it's a little bit challenging, but our age range is wide, so sometimes we can even think about like a year from now. It's not a research that's going to be done in 2 months. So we expect to recruit for the next year or so we have time.
Wonderful. Thank you for that. And we will be sure to include all of the contact information for the study in the follow-up email with the webinar recording link. So if anyone has questions relating directly to the study, they can be passed on directly to this team there. Are you familiar with the current clinical trial of NAC for motor behavior and learning in NF1 kids?
NAC?
Yeah, and I'm going to completely butcher this name, N-acetyl-L-cysteine for motor behavior.
Cysteine. I'm familiar with the study for PTN-10, but I'm not familiar with NF1. I know that the results with the other conditions are very not definite, but I cannot say beyond that. So this is the level of my information, but I'm happy to hear more about it.
Wonderful. And I think we've got one last question here. Dr. Green, have you studied any NF1 children with related brain tumors, and how would that relate to stratum?
To the stratum?
Yes.
Yes, yeah. So, you know, as you probably understand, we are just starting now, but from the literature and what we kind of like understand is that all the conditions that I mentioned are independent of if a child has a tumor or glioma or so of course if a child needs to go chemotherapy or brain surgery, that might has its additive effect on the conditions I talked about, but generally speaking, they are unrelated. I'll give another example. Many kids with NF1 in their imaging, there's these flares that we see in a specific type of imaging called UBS, and we know that they're not actually affecting as far as we understand now, they're not affecting those conditions. So I hope it's answering the question.
I think so, absolutely. Okay, I think that about answers all of our questions at the moment. Like I said, we will be including all of the contact information in regards to this study in the follow-up email with the webinar recording. I would like to give another huge thank you to both Dr. Green and Tammy, and obviously our member organization, NF California, for being a part of the webinar tonight. To stay up to date on all of our future webinars, please do sign up to stay informed. We also give future updates in NF research, upcoming events, and so much more. Like I said, the webinar recording will be posted on the NF Network website tomorrow, and you'll also be receiving an email tomorrow night. A huge thank you. Everyone have a wonderful night, and thank you again for joining us.
Thank you very much for inviting us.